So this is becoming an annual tradition, I think. We've done this for a few years now, and I really enjoy looking back at my previous suggestions and seeing what I think I've learned from the previous exam and during the year that's happened since. So this is the 2013 edition of AP Statistics Exam Tips. My number one tip is kind of a no-brainer. I'm going to give this to my students tomorrow. They should have been preparing all along, but obviously you want to be well prepared for the exam. How do you get well prepared? You do practice AP exam questions from previous exams. That includes both the multiple choice. And I just wanted to list the sources of all of the released exams now. 2012 is the most recent released exam multiple choice. 2007, which is available for purchase from the College Board or has been obtained by some of us at summer workshops. The 2002 exam available for purchase from the College Board, and the 1997 exam, which is a free download from the AP Central website that we'll be heading to in a little bit. There's also the quote-unquote secure AP Audit Practice exam that was released soon after a lot of us did our audit. The problem is it's not secure. It's actually pretty easy to Google search it and find it on the internet. So you don't want to treat that one as secure. But the 2012 exam is the one a lot of us are using for our multiple choice because it really at least appears so far to be fairly secure. On the free response, you can get all of the free response questions dating back to the beginning, that is 1997, here on AP Central. So I've gone to the AP Central page, and I'm going to go ahead and take advantage of Cindy's polling opportunity. Just to show of hands, those of you who have gone to this very page and used questions from here with your students already.
So again, to do the polling, if you click on Viewing Daren Starnes Desktop, you'll bring up that participant box. And okay, seems like
it's good to see so many raised hands. What's great about this resource is that not only do you have the questions, but you also have the scoring guidelines. You have information about how the students performed, scoring statistics for the exam, as well as sample responses for each question and the score distribution. So for each year, you have that, and you also have it for the so-called Form B or overseas exams from 2011, going back to when the overseas exam was first started. Oh, we already have a hand.
We have a hand.
Cindy has a hand.
I have a hand, yes. I've also wondered, are the score distributions, do they curve them? Are they looking for the bell-shaped curve? Or?
So the score distributions to decide who gets a 5 and how many points that requires out of 100 is set each year, but it's not always made public. So if you get the 2012 released exam multiple choice, there is a page at the end that shows the cut scores for 2012, but you can't use that set of cut scores for any other year because they are specific to that particular exam. So it's really interesting that the chief reader and the statisticians from ETS gather in a little room after the exam is over and the points have been totaled and decide on where to put the cut line for the 5 and the 4 and so on. But I think the one for 2012, if you use that exam, gives you a good sense of, for example, you might need 70 points out of 100 to get a 5.
Okay.
It has varied quite a lot. If you look back at 2007, you'll see very different score breaks than you do now in 2012. So some exams are a little easier for the kids, some are a little harder. There are some common multiple choice questions that are used from one exam to another, and so they look at the performance of the current year students against the performance from a previous year. If the current year students do better, then they can make the cutoff for the 5 maybe a little bit lower. They can give more good scores. If this year's group does about the same, then you should expect similar percentages of 5, 4, 3 scores. And if this year's group does worse, then you're going to see fewer high scores. Over the last couple of years, we've seen kind of a consistent performance on those comparative multiple choice questions. So if you look at the score distributions from the last few years, the percentage of 5s, 4s, and 3s has not changed very much. Okay. So good question to start off. So this is a wonderful resource, and my students are getting the benefit of lots of these questions over the next couple of days. All right, so let's return to getting prepared. There are obviously practice questions from other sources, but I would argue that none of them are as good as the ones that you can get from the College Board, the released exam questions. A few decent sources, those of you using the Practice of Statistics 4th edition know that there are some cumulative AP practice tests at the end of chapters 4, 7, 10, and 12. My students just did the one at the end of chapter 12 this past week, and that is a full-length AP-style practice test written by Michael Legacy, who was on the test development committee a few years back. Another source that I have been using with my students this year is the Strive for a 5 AP study guide that was written by Stats Monkey, Jason Molesky. My students have really given a thumbs up to this book. They've used the multiple choice questions throughout the year for each chapter, and now they're using some of the practice tests to get ready for my mock exam tomorrow and Friday. They've really enjoyed, this is the first year we've been able to use that resource, and my students at least give it high marks. Another great website that I want to show you and then poll people about is in its second year of existence. This was funded by a National Science Foundation grant last year, and it's called Stats for STEM. Could I see a show of hands? How many people have used Stats for STEM, either this year or last year? A few of you. That's terrific. Well, those of you that haven't, this is a wonderful resource for us that's absolutely free. And as you can see, as part of this National Science Foundation grant, 14 review assignments totaling 420 questions were put together that you can use over a series of days, either for homework or in-class work. You can set up a class login so that you can monitor students' performance. So I realize that at this point in the year, I'm probably talking about next year, but for those of you who are going to be taking the course again next year, this is a terrific resource to think about. And the questions, as my kids describe them, are pretty challenging. They're not easy. And at this point in the year, I don't want them to have too many easy questions. So that's an excellent little resource. Another thing in terms of getting prepared is to be sure that the students are really familiar with the formulas and tables that they're going to be provided with on the AP exam. A lot of us give those to the students throughout the year on our class tests, but I find it doesn't hurt to just take one more look at the formula sheet and be sure they know what every single formula is. There's a condensed version of the formula sheet in the back of the 4th edition for the Practice of Statistics that we condensed onto one page. It looks like I've made some editorial marks on it as well. How about that? Got a strange multiplication dot there. So this one-page version is in the Practice of Statistics 4th edition so that you don't have to keep Xeroxing 4 or 5 pages worth of formulas. And the same with the tables. The tables are very strikingly similar to the ones on the AP exam. And that makes it, I think, easier for students to use the tables in our book and then at the end of the year use the ones on the AP exam without too much difficulty. They look just the same. The other thing that really does pay dividends in terms of helping students' scores is to review the inference procedures. Remember that inference is going to account for 30 to 40% of the exam questions, and so doing well on that one segment of the course could really reward the student. There are two wonderful resources here. One is my all-time favorite website from Lake Tahoe Community College. Larry Green, an instructor there, has put together a terrific site that allows students to practice identifying which inference procedure to use based on a description of a study. So all you have to do is load it. You can do this in class, or you can have students do it at home for practice. I'm just turning off the ones that we don't do in the course. But here's an example question. Does the general public respect politicians more after an election than before? I wonder. 500 people were asked if they respected politicians before the election and then after the election. So based only on that description, students are expected to come up with which inference procedure they're supposed to use. So in the last week or two before the exam, I have this on my smartboard waiting when the students come in, and they know the drill. As soon as a few of them are there, they'll start debating it, and they'll click on the one that they think is right, and they don't want to get embarrassed, so they will debate it before they click the button after the first few wrong answers. And as you can see, it could be a confidence interval, it could be a hypothesis test, and so students really do have to grapple with which one it's going to be. So knowing my students, when they first did this site, they would look at it and they would say, well, is it a confidence interval or a test? Sounds like a test because you're just asking a yes or no type question. Is it about a mean, an average, or is it about a proportion? Well, it seems like a yes-no kind of thing. Do they respect politicians or not? So I'm thinking proportion. And then you're comparing a before and after. So my students are probably going to pick something like test of the difference between two population proportions. And then they're going to get happy feedback. So the immediate feedback is wonderful. I'll just show you one more. Could I do the poll again and find out how many of you have used this site with your students? I don't want to spend longer on this page than I need to. I know some of you have.
So again, if you can click on the hand to indicate if you've been using this site with your students.
Looks like four or five hands.
4 or 5.
Yeah, that's great. Those of you that haven't, it's a great resource. So I'm going to purposely miss one right now. I need to look at it enough to be sure I'm going to miss it. Will plants grow larger in artificially fertilized soil than in organic soil? I believe that should be banned. 55 plants were grown in organic soil and 55 plants in artificially fertilized soil. So I'm going to botch this one up and say confidence interval for paired data. That's totally wrong. And you get feedback again. We want to make a decision, not estimate a value. This is not a confidence or prediction interval. Please try again. If I do hypothesis test for the difference between two means, I think I get it right. So another wonderful resource for getting prepared. I'm sorry this first slide is so long, but it seems to me like that is the best advice that I can offer students throughout the year is to get ready. And if you get ready and you know your stuff, you're going to do well on the exam. But I do have a few more slides, so this is the number one suggestion, get prepared. The second suggestion I have for students is about the exam itself. Students have to pace themselves carefully on the two sections of the exam. So in order to do that, they need to be thinking about entering the exam well-rested. They need to get a good night's sleep. Our exam happens to be in the afternoon on a Friday this time, which is not ideal. Friday afternoon is not my favorite time slot, but at least it is an afternoon. Unfortunately, it follows an exam that's English, so they're going to have to write a lot. So I'm concerned that they have a good night's sleep and that they hopefully will get a good lunch. Another thing I suggest for my students the night before is to review the AP exam tips that are accumulated in the appendix of the 4th edition. Just do a read-through and be sure that they calibrate themselves with all of these little reminders because I think there are some valuable hints that they may have forgotten about that might help them earn an extra point or two. And that extra point or two might be the difference between a 3 and a 4. So it could really pay dividends in terms of earning credit for the score. There's that healthy lunch. I knew it was in there. The other thing I remind them to do is to check that their calculator is working and that their batteries are fully charged. It's okay for students to bring 2 calculators to the exam. It's okay to make sure you have really good batteries. You'd hate for the thing to die partway through. So let's talk on the exam itself. The multiple choice section, 40 questions, 90 minutes. Each question counts the same as each other question. So it's really not worth getting bogged down on one question because while you're doing that, you're probably missing the opportunity to answer another one. So my first tip is not to spend too long on any one question. If they get bogged down, they should just move on and circle it and come back. A hand.
So there was something that changed, right, with the exam about making it better to guess, like when you can... Yes,
exactly. So one of my, it's on the next slide, tips about scoring rather than pacing.
Okay.
But yes, a couple of years ago, the quarter-point penalty that was applied for incorrect answers was removed. So now one of the strategies that you'll see me remind folks of is that students should answer every multiple-choice question. It absolutely is beneficial to their score to answer them all. On the pre-response question, we have 6 questions in 90 minutes. And from experience, students finish the multiple choice section usually with a little time to spare. That isn't as true with the pre-response section. We've actually had years where I had a number of students not finish the pre-response section. So with that in mind, you don't want to run out of time before you get to the final question. And that's not just because you would not want to run out of time anyway, but the sixth question counts more than the other questions. So you don't want to run out of time on the one that counts more. So that's an important strategy issue. So you want to start with some questions you feel confident about out of the first 5. My student strategy is the 3 of the first 5 I want them to do completely. And then I want them to go to number 6 and try to get part of it done. So a little bit more on that when we get to the scoring slide next. But pacing is a real issue for kids, and I found that the kids really don't want to work out of order. They really have a hard time following my advice of do 3 out of the first 5 that are on topics they feel really good about. Then go on to question 6 and get started on the first few parts so that you don't get a 0 on question 6. More on that on the next slide. So getting prepared, pacing yourself. And tip number 3 is know how this exam is scored. Try to maximize your score by knowing how the scoring works. So in the multiple choice section, there are 50 points possible. That's half the exam score. 1.25 points for every correct answer. So you might as well answer them all. You might get lucky. You might be able to narrow down a few options, in which case it makes it a little bit more likely that you'll guess correctly. The free response is also worth 50 points, but it's divided up in an interesting way. So each question is scored holistically on a 0 to 4 scale, with 4 being a complete response. So on questions 1 through 5, your total possible points on the 4-point scale is 20. You multiply your total by 1.875, and that gives you a score out of 37.5. Question 6, your score from 0 to 4 is multiplied by 3.125. So look at what happens if you get a 0 on question 6 because you don't get to it. You've just thrown away 12.5 points from the free response section. That's a really bad idea. Nobody would want to do that. If anything, it's much better to omit a question earlier. If you think you can earn a couple of points on question 6, it's going to be much more valuable to you. So I'd rather the kids run out of time on a question from 1 through 5 that they're really weak on. Hopefully they're not weak on too many.
And is question 6 multi-part? Is that
It is. It's going to be multi-part, with the first few parts being things they're familiar with that they'll probably be able to do relatively quickly. And then as the problem goes on, it goes way outside the box. So it emphasizes transfer of knowledge to an unfamiliar setting that's not like anything they've seen exactly before. So really your creative thinkers, your outside-the-box thinkers are going to do better on that question 6 at the later parts.
There's a question that came in. Do they give you a time warning during the test to help kids pace themselves?
So there is a time warning. If you take a look at the 2012 released exam that you can get through your AP audit site, the proctoring directions that the proctor reads are actually in that booklet. I found that fascinating to read because I don't think I had done that in a number of years, but it tells you exactly what the proctor says and when, so you can see when the time warnings are going to be given to the students. I had hoped that there would be a time warning a little earlier in the free response, but there's definitely one when you get down to the 25-minute mark remaining, because question 6 is suggested at about 25 minutes.
And it's just a verbal...
It's a verbal, you've got 25 minutes left, you might want to be working on question 6 now, which is fine if you really are working on question 6. A little more disappointing if you're just through the first 2 questions or something. So you still have to self-pace to a large extent. Great question. The how many points to get a question came up earlier. So here was the 2012 released exam. You needed 70 points to get a 5, which is the top score, 57 points to get a 4, 44 points to get a 3, 33 points to get a 2. And as we all know in our classes, for some students, a 2 is a really monumental accomplishment. That really does represent terrific growth and work for them. For other students, not getting a 5 is disappointing because they've been really doing well all year long. But if you look at those numbers, just think about a kid who manages to get half the multiple choice correct, 20 questions out of 40, and half the points on the free response. They're going to get a 50, which last year would have gotten them a 3. Mm-hmm. So half the points, you're definitely going to earn a passing score of 3 or higher. In some years, if the tests were particularly tough, you might even scratch out a 4, but I'd just say to my kids, you will get a passing score of 3 or higher if you earn half the points. And for many of the kids, that seems like a realistic goal. So knowing the score is definitely a way to help your total. Now I'm going to get into some of the more strategic things that you can do during the test to help you earn a few more points. One of them is using technology wisely. So a terrible time waster for kids and a bad habit that some have developed is as soon as they see long lists of data on the page, they'll start typing it in. And on many of the AP exam questions, the data are provided because that's just a good thing to do in a statistics class, but the kids don't actually need to type the data into their calculators. So it's important that the students read the question and not just start mindlessly typing reflexively. On inference questions, where they're doing a hypothesis test or a confidence interval in the free response, they should absolutely use the stat test menu to do their calculations. My students will all do this. And in terms of using the formulas that are provided on the formula sheet and substituting values in, the only reason my students will do that is if they have extra time and want to try to earn partial credit. My kids are willing to risk all or nothing on the calculation part of the inference questions because they're just more likely to get the credit. My students using the formulas under time pressure are going to make mistakes that are going to cost them points. So yes, you heard me say my students will use stat tests to do all the calculations on the inference questions.
So a question came in, I think you might have answered it. Can the students bring extra batteries to the exam? You recommend that they do bring extra batteries, or?
I would check that Proctor guideline in the 2012 exam because I don't recall what the permitted materials are that they can bring in with them. I would assume that makes sense. I know another calculator is permitted, but I'm actually not sure about extra batteries.
Okay.
You could also ask your AP coordinator because they're the ones who have to make sure that the proctoring is done according to the rules. That's a great question I couldn't answer. Need to say a word about overusing the calculator. You can hear I'm very pro-calculator in terms of computations. That would apply when you're doing probability calculations as well, like normal probability calculations, binomial probability calculations, geometric probability calculations. You could overdo it. And so, for example, if you're doing a binomial probability calculation and all you write down is binom PDF 12, 0.2, 3 equals number, you're not going to get full credit for that. You have not indicated what the parameters are of the distribution that you're using. So yes, I know that the first number is n, and the number of trials, and the second number is p, the success probability, and the third number is the number of successes you want to get. But on some calculators and in some software, the syntax is different. So we require the students to identify not only the distribution that they're using, but also the parameters of that distribution clearly. So one definite way to do that is with the good old-fashioned mathematical formula that's provided on the formula sheet, as you see here. Another option, though, is use the calculator command, but indicate that n is 12, p is 0.2, and k or x, whatever you use for the number of successes, is 3. You have to label those inputs, those parameters that you're using for your distribution. Here's another example with the normal distribution. Kids can use normal CDF. If they just write that with the answer, no credit. In my opinion, better, find a z-score and then shade a normal curve to indicate what you're finding. But the minimal would be use the normal CDF command and indicate that 90 is the lower bound, that 105 is the upper bound, 100 is the mean, and 5 is the standard deviation. So students should not expect to get full credit if all they write is calculator speak with an answer. They need to label those inputs. So this is something that's trainable and that can save them the loss of some credit if you tell them right now. It's very clear, very easy and clear to tell them that. This one's huge. On inference questions on the free response, students need to follow the 4-step process. But the grading rubrics are very consistent on these free response questions. So the 4-step process, as we presented in the 4th edition of the Practice of Statistics, looks similar for confidence intervals and for tests. And when you see the grading rubrics, they're also similar. So the 4 pieces are stating something about your parameters, planning what method you're going to use and checking the conditions for that method, doing the calculations, which I've already told you I recommend stat test menu, and conclude in context. So I thought it would be helpful to look at a question from last year's exam and show you how that four-step process plays out. It's a wonderful little question, and one that I definitely recommend using with your students. My students will be using it in 2 days when they do their mock exam. Please don't tell them. Don't tell my students. So this question is about a survey that was conducted using telephone interviews, first in December 2008 with 1,009 randomly selected adults who answered this question. At the present time, do you think TV commercials are an effective way to promote a new product? The same question was asked in December 2007, and you can see some results. In the first December 2008 survey, 676 responded yes out of 1,009. In the December 2007 survey, 622 out of 1,020 said yes. Do these data provide convincing evidence that the proportion of adults in the United States who would respond yes to the question changed from December 2007 to December 2008? It's a wonderful problem. I think it was designed to be a two-proportion z-test, a hypothesis test for comparing two proportions. But in fact, those of you who've studied this a little bit know that you could also do a chi-square test for homogeneity, or you could also do a confidence interval for the difference in proportions and use the confidence interval to answer the question. There are three valid inference methods for this question. But the majority of students attempted to do the two-proportion z-test. Let's look at how the rubric would have scored this. Step one, this is our state. State your hypotheses, define your parameters. So the hypotheses you can see here, null hypothesis, P07 equals P08. Alternative hypothesis, P07 does not equal P08 because it asked, did the data provide convincing evidence that the proportion changed so that there is a difference. That's why the alternative is two-sided. And you can see here how the parameters are defined. P07 represents the population proportion of adults in the U.S. who would have answered yes. I know I'm making a big deal about the would have answered, but that'll be important here in a moment. And P08 is the analogous proportion for December 08. Your students need to be able to define their parameters when they're doing a hypothesis test or a confidence interval in terms of the larger population distribution that they're sampling from. So there's the first step, stating hypotheses. Step two is to identify the procedure and check the conditions. So in this case, a two-sample z-test for comparing proportions, or what the calculator calls a two-prop z-test. And yes, it's okay to call it that. And the conditions are, first of all, we need independent random samples. You can see that combine those two pieces, independent random samples. This condition is met because we're told that the subjects were randomly selected in the 2 different years. And the second condition is that you need to be able to use the normal-based calculations, the normal approximation, in order to do your test statistic and p-value. So that's met because we have expected counts that are very large. So in this case, the yeses were 622 and the no's were 398 in 2007. The yeses were 676 and the no's were 333 in 2008. Those are all big enough, at least 10. And the other condition that some students would check is the independence of the observations in each sample. So because we're sampling without replacement, we need to check the 10% condition that the populations are at least 10 times as large as the sample. The two really critical ones in the scoring, as you'll see, is the independent random samples, plural. So students needed to indicate that there were 2 random samples, one from each year, and the large counts for the normal approximation conditions. That last one was not required, but some students mentioned it. The third step is the calculation. You're going to see a lot more on here than what my students are going to write down. This is the old school writing it all out with the formulas approach, kind of the model solution for the math teacher, which all of us are. And so this might be how a lot of us would have written it out 20 years ago or more. And you can see the test statistic, -2.82, p-value 0.0048. Again, my students are just going to type in the appropriate things on their calculator and write down the answer. There's my tip. Use technology. Makes it a lot easier just to type that into the stat test menu and get the results, because all you have to write down here is the test statistic and the p-value. That's it. It gets you 1 point if you do it correctly. On step 4, we need to do our conclusion in context. Notice here the p-value is smaller than 0.05 or 0.01, or it's just very small. Therefore, we reject the null hypothesis. That's piece number 1 of the conclusion for a hypothesis step. Piece number 2 is a statement about the strength of evidence for or against HA. So I'm trying to help my students get this straight. The first sentence is about what you do with HO, reject or fail to reject. The second sentence is about HA. So in this case, we do have convincing evidence that the proportion of all adults in the U.S. who would answer yes to the question, who would answer yes, changed from December 2007 to December 2008, which answers the original question. Notice that it says who would answer yes. A lot of the students got caught up and said things like, who answered yes. If they said who answered yes, now they're not referring to the population, they're referring to the sample. Because the only people who answered yes were the people that answered the question. That's the sample. So if you said answered, you're talking about the sample. If you said who would answer, you're talking about the population. Kids can easily make that mistake. So they need to be very careful how they say these things. I mentioned before, chi-square test for homogeneity is completely valid, gives the same result. So would a 2 proportion Z interval. Calculate that interval and see if 0 is contained within the interval as a plausible value or not. Students would still have to go through the 4-step process for those other procedures. And as you can see, this was the primary procedure that was published on the AP exam rubric. So this is a biggie. Remember, inference is 30 to 40% of the exam score. So you want to be sure that your kids are trained in this 4-step process. We're halfway home. That was a big one, and so was number 1. But I think I alluded to this just a minute ago. The kids need to watch what they say very carefully. We are all watching them carefully, all of us AP readers, and we're sort of like figure skating judges. We have to do a mandatory deduction if they say something that's statistically incorrect. We actually have no option. We have to deduct for that. So students have to watch what they say, both in terms of vocabulary and notation. If they use a term on the topic outline incorrectly, we have to notice that and we have to deduct for it. If they use a symbol incorrectly, we have to deduct for that. So I'm sorry, I've been training my kids on this all year long. If you're not sure what to do, you should not use one of the terms on the topic outline. You should say your own words. You should not use a notation that you don't know. But inevitably, what students will do is use statistics instead of parameters in their hypotheses, so they'll write things like this. And as soon as we see that, we have to deduct for it. We know that they mean something about the sample mean, and that's unfortunately not what the hypothesis should be about. Throwing out buzzwords like in an observational study or an experiment saying something about confounding. Well, the exam questions have been designed so that students are going to be exposed if they just throw terms around. So trying to say that there is confounding puts the burden of proof on the student to suggest how the variable that they think is interfering with this relationship really is related to both group membership and also to the response variable. And most students don't do that. Using experiment language when they're actually in an observational study where sampling is being done. So for example, saying things like, they used blocking when they took the sample. That's an immediate deduction. That means that the student's using the wrong kind of language. I call it speaking French in Spanish class in my classroom, and the kids know what I mean. So kids have to be really clear on the terminology. My advice, only use the terms and symbols that you know. It's better to explain it in your own words than to use a term or symbol incorrectly. So you can use words. It's okay to write population mean equals 8 as your null hypothesis. It's okay. Better than writing X bar equals 8 and getting a mandatory deduction. Another piece of advice along the same lines is to not write too much because of the mandatory deduction rule. Less really is more on this exam. And from my students who take other AP exams, I get the sense that this may not be true.
That's not true.
On some of those humanities exams, that you might want to write a little bit more and be sure you've covered all the different angles. That's a really bad strategy on this exam. Shorter answers tend to be rewarded in the sense that they don't suffer from the mandatory deduction rule.
Well, and I'll interject, in the humanities, you don't get points off for being wrong.
Well, you do here. So let's be clear, this is a math exam. So my advice to my kids, if you're allowed to say shut up in your class still, I am at my boarding school, answer the question and then shut up. Don't keep elaborating with one more thought that you just thought you should throw in there, or one more little impressive piece of terminology like confounding that you feel like you need to dump on the paper. Don't do it. Once you've answered the question, shut up, move on. The space provided on the exam questions is more than enough for the kid with the biggest handwriting in the class to fit their answer, as long as they don't start rambling. So I've seen students produce really good quality answers in half to two-thirds of the space provided. So I want my students to be nervous if they're filling up the entire space. And I've tried to make them nervous throughout the year by making mandatory deductions when they make errors as they ramble on. So please discourage rambling on. The other really bad strategy on this exam is to try two different things on the same question. We call that parallel solution. So you're not quite sure what to do, so you try two different things that give you two different answers, hoping that the grader will show mercy on the one that's right. We don't show mercy. Those of you who graded the exam can reaffirm. If we get fundamentally different solutions that are parallel and different, we will mark the lower one. That is, we'll score the one that counts for fewer points. So if you have a completely right solution and a completely wrong solution, we're going to grade the completely wrong one. We actually want you to be able to decide what the best approach is, or what a valid approach is. So you shouldn't do parallel solutions. Another little issue that reminded me of the calculator speak is the naked answer, the bald answer. Students should expect to get no credit at all for a naked answer with no work. At the very beginning of the free response section, there's this message: show all your work. Indicate clearly the methods you used, because you will be graded on the correctness of your methods as well as on the accuracy and completeness of your results and explanations. It doesn't say on every, not every part says show your work or justify your answer, but if it doesn't, this covers it. So students should always be showing their work. And here's an example from last year's exam on a probability question. They had a little spin the spinner game. So you spin the spinner and you get money for charity. So you pay a $2 donation to play the game. You're allowed to spin the wheel once. So there's the wheel again. Spin the wheel once for your $2. And the amount of money that you win is indicated by the spinner. So you pay $2, and more than likely you end up not winning very much. But there is that little chance that you come over and win $10, and you don't give anything to the charity, they give you money. So the students are supposed to fill in the probability distribution as part A based on the spinner, calculate the expected value for part B, figure out the fewest number of times the game must be played for the expected value to net the contribution of $500 for the charity, and then calculate a probability based on the normal distribution, which they give all the parameters for in part D. So the only one that really doesn't require work be shown is part A, because it's fairly easy to count the number of sectors on the spinner and fill in out of 10 on the chart. So when you look at the scoring, you'll see section 1 is essentially correct if all the probabilities are filled in on the table and the expected value is calculated correctly in part B with work shown. So you have to show the work in part B in order to get credit for this section of the question. So they could have kept part A as its own thing and given full credit for no work, but they chose not to. They lumped it with the first part of the calculations in B. And then section 2 is for essentially correct if the students provide a reasonable calculation, equation, or inequality based on the answer given in part B, and selects the next highest integer as the answer when they're trying to figure out how many games need to be played in order to maximize the profit for the charity to gain at least $500. And then the final section is the one about the normal probability calculation, which also requires work. And you can see 3 pieces of the work: normal distribution with the mean and standard deviation indicated, the boundary being correct and the correct direction on the problem, and then the correct normal probability based on the answers that they should have had from parts 1 and 2 there. So work is required in order to get full credit, and no work at all with a naked answer, even if it's right, should be no credit. So that's a hard message for kids in a math class who may have been rewarded for the answer on other exams. Even the calculus exam, I think, gives 1 point for the correct answer. We don't. Naked answer won't necessarily get any credit at all. That's kind of harsh. All right, I've got 2 more messages here, and then I want to leave time for questions. So one that has plagued me over the years as a question leader and in my class is, which distribution are you talking about, little kiddo? There are 3 possibilities. The student could be talking about the distribution of the sample data that's provided on the exam question. The student could be talking about the larger population distribution that's out there. Or the student could be talking about the sampling distribution of a statistic, like X bar or P hat. Quite often the exam questions are about this last one, but the students think they're talking about one of the other 2. And question number 6 from last year's exam really made students shift between these 3 distributions. So there's a question almost every year that has students trying to navigate these 3 distributions well, and they don't. So if your students can get comfortable figuring out which distribution they're talking about and not just saying, it is approximately normal without describing what the it is, you'll definitely help your students on at least one of the questions of the free response. So this one was about Peter and Rania, who were trying to estimate the average number of soft drinks that students at their school consume, and they give some information about how they're going to each take a sample. Peter took a simple random sample of 100 students, but Rania decided to take a stratified random sample, 60 females and 40 males, and ask all the students how many soft drinks they usually consume in a week. They then calculated estimators based on their sample. Peter just calculated the sample mean, X bar. Rania did a weighted average, 0.6 times the female mean plus 0.4 times the male mean as their point estimator. And then the question continued by asking the students, for example, how would they calculate the estimated standard deviation of the sampling distribution of Rania's point estimator? And I can tell you that a lot of students didn't realize they were being asked about the distribution of the statistic that she calculated and not about her data and the sample data. So they were clearly confused about what distribution they were working on. My final tip, maybe the most important one other than being prepared, is cleverly abbreviated RTQ and ATQ. Credit to students and colleagues for coming up with the acronym. So this was the question I was question leader for last year. Question number 2 about independent random samples of households question 3. Independent random samples of 500 households taken from a large metropolitan area in the U.S. for 2 different years. And histograms of household size for the years are shown here. So you can see in 1950, the household distribution was clearly skewed to the right, and in 2000 it was also clearly skewed to the right. But it looks like the center of the distribution was a little higher in 1950 than it was in 2000. So households tended to be slightly larger in 1950. The variability was slightly higher in the 1950s. You can see the range is a little bit bigger, from 1 to 14, so the range is 13, whereas in 2000 the range is only from 1 to 12, so 11, the range is 11. So a little bit more variability in 1950, a little bit higher center, so slightly bigger household size on average. Both are right skewed. And the question asked students, first of all, just to compare those distributions. So if you've read the question and you see this, you should immediately be thinking shape, center, and spread, and also compare. So we want students to say things like, both distributions are skewed to the right. The distribution of household size in 1950 seems to be centered at a higher value than the distribution of household size for 2000. And they might even give evidence of that from the median for those 2 years. And then that the spread of the household sizes, or the variability in the household sizes for 1950, seem to be slightly larger than the variability of household size for 2000. So if they compare those 3 things, that's what we're looking for in Part A, and they're done. And then in Part B, they're asked to talk about conditions for doing a 2-sample T procedure to estimate the change in mean household size with a confidence interval. and then explain whether the conditions are met. So students who are not careful readers actually just stated the conditions. They never saw the explain whether the conditions for inference are met. The not-so-careful readers also sometimes skip the first part and just explained whether the conditions were met, but didn't actually say what they were. They never identified them. So you can see how a student who isn't reading carefully will not be able to score full points on this question, even though it's a fairly straightforward question. So the advice here, read the question, RTQ, and then answer the question that's asked, and shut up. That was an earlier tip. So ATQ, RTQ, and ATQ. Quick recap before we take some questions. Get prepared. Students need to pace themselves on the exam or they're going to run out of time on that free response. Don't want to get bogged down in the multiple choice. Skip over one. Come back. Know the score. Be sure to answer all the multiple choice questions. It's worth guessing at the end whether you can narrow down the options or not. You need to answer them all. Use the technology wisely. Use that stat test menu on those inference questions to save time and get it right. Follow the 4-step inference process. That's what we're going to grade it based on for those inference questions. Watch what you say. Watch those terms. Watch that notation. Don't write too much. Mandatory deduction rule. Naked answer equals no credit. Avoid parallel solutions on number 7 as well. Which distribution are you talking about? Sample, population, sampling distribution of a statistic. Read the question and answer the question. Those are my 10. I'm hoping we have some questions. Cindy's my monitor.
Anybody have questions? You can, if you raise your hand, I would click on your microphone and you can just ask your question. Or if you feel more comfortable putting it in the chat, you can send your chat message to Daren and I will read it for you. We're getting thank you.
Oh, I'm getting thank you. Well, somebody's going to ask a question. Don't soft pitch me. Are they being bashful, Cindy?
I guess they're being
bashful. You like my students in class?
And maybe you've anticipated everybody's. Well, I'll ask a question. What's involved with being a reader? How does one become a reader?
Oh, once you've taught the course for 3 years, you're eligible to apply to become a reader. And I strongly encourage you to do that. The other people who've been readers that are on the webinar can tell you how powerful a professional development experience that is and how much interacting with other colleagues at the reading can help you improve your teaching and help you improve your student scores by knowing those little things like the ones I've been sharing tonight. All you have to do is go to AP Central and apply to be a reader. You probably won't get invited in the year that you apply, so I recommend doing it in your 3rd year or as soon as you are ready to apply after that, because it might be a year or 2 or 3 before your number comes up. But once you've submitted your application, you get a little email from ETS to say you're in the process now, and as soon as the slot becomes available, then we'll be in touch.
All right, we do have a question.
Yay!
Regina, you want to ask your question to Daren, please? Regina? Oh. On the free response questions, if we use a calculator to get an area of probability, should we show the application of the table method?
No. You should use the calculator and label the inputs of the command that you used, if it's binom or normal. No need to use the table.
Okay, and then from Lou Davidson, to show work for an unexpected value calculation, would it be acceptable to say that the one varistat with the probability is the frequently listed option?
No, thanks, Lou. It would not be okay, actually. On the calculation of expected values or standard deviations for random variables, you actually have to show work in the form of a value times a probability. You don't have to show every value times every probability and then adding them all together, but you do need to show a value times a probability plus at least ... to show the method. I know a lot of students do it with the one-bar stats, L1, L2, or with a frequency list, but writing one-bar stats and frequency list is not going to get full credit there. The students actually have to show a value times the probability. So that's actually a case where the calculator is just a little too different from what's done in practice, although knowing that they should do the frequency list times what's in list 1 is great. So they might get partial, but they shouldn't expect full credit unless they show that value times probability. That's a seasoned question there. Way to go.
Another calculator question. If students use the calculator, they do still need to name the procedure even if they don't use the formula, correct?
They definitely need to name the procedure. That's scored as part of step 2, which is the plan. They have to name the thing that they're doing on the calculator.
Sorry, already asked that one. Any others for Daren? On multiple choice questions involving student T distributions, can we expect answers to be based on a table or calculator?
Oh, good one. You know, it could go either way. And you notice my recommendations about stat tests were primarily directed at the free response section. Those devious test development committee members could easily put questions in the multiple choice that require students to know what a formula looks like with values plugged in. So I'm not saying you shouldn't teach students about that, but on the free response, my students aren't going to write out those formulas and plug in the values. But it's easily possible that there could be a question on the multiple choice where students need to look up a critical value in a table. Okay, actually they could do it on their calculator with inverse T also, but there could be a problem that requires them to look at a formula with the numbers plugged in and know what kind of procedure is being done. Hope that got it. I kind of added some things to the answer.
Any other questions? This is your opportunity.
Well, while people are thinking about whether you have one final question, I just want to wish all of your students good success on the exam a week from Friday. I hope that at least one of the tips is something that you feel like you can share in class next time you see the students, maybe more than one. And I hope that some of the tips actually result in students earning an extra point or two that they might not have earned otherwise. I mean, that's the whole point of doing this, to try to help the students do the best they can. So I'd be very happy if your students come out of the exam with tremendous scores. Just don't do better than my students. I don't want to give away all my secrets and then have you outscore my kids.
Very good. Well, if there are no more questions, a question about getting copies. Yes, so Daren did reference the Practice of Statistics 4th edition, which W.H. Freeman of BFW publishes. And we do have the great wraparound teacher's edition that Josh Tabor has put together in addition to the student edition text. And you can request it either emailing me. You should all have my email address as you got the invitations for tonight's session. Or go directly to your representative to request a consideration copy, or go on our website, the BFW publisher at high school website, to request a consideration copy. And there was a question earlier about the appendix that Daren showed, the AP exam tips. That's actually from the 4th edition. It's an entire appendix that goes chapter by chapter to help students with, in preparing for the exam. And as Daren said, this is a great time for them to be reviewing those tips.
Can I say something nice about Josh Tabor's Teacher's
Absolutely.
Edition? I had the pleasure of using the Teacher's Edition last year for the first time, and just got so much out of Josh's wisdom, both as a former test development committee member and also a high school teacher in Arizona, to be able to use some examples that were his rather than the ones that I had put in the textbook was really refreshing. And I thought that his additional suggestions for teaching, for activities that we put in the book were especially helpful as someone who was himself trying to implement those activities in the classroom. So I can't say enough nice things about how that really helped my own teaching and hopefully the teaching of other people out there who use that resource.
And I will capitalize on what Daren's saying with the examples. I mean, the practice and statistics, whatever edition you're using, has a wealth of examples throughout the text. What Josh has done that Daren's referencing is for every single example that exists in the student edition, he has provided you with an alternate example to share with your students. So it's just a really powerful resource